Okay, we have, we want to graph the following equation using x-intercepts and the line of symmetry. So in this situation, we're going to, it's a parabola, and so we have an equation that's y is equal to negative 3x squared minus 4x plus 2. Okay? And so from there, we are going to look at a few things. First things first, we need a good point of reference. One thing we should remember, or we should recall, is the fact that I run out of ink all the time. And then the other thing is the fact that this parabola is going to tell us whether it's smiling or frowning. We talked about that the other day. It's, in this case, it is frowning, right? Because the front coefficient is negative. The front coefficient is negative, therefore, this thing is frowning. So I already know this is frowning. I don't know where it's frowning, but I know it's going down. So there's going to be a maximum point on this parabola. The other thing I know is that I need to find the derivative in order to find the special slope, right? So the derivative is going to give me an idea of tangents along the curve. So y prime is equal to the exponent times the coefficient, which would be 2 times negative 3 or negative 6x, and 1 from the exponent, which is 2 minus 1 or 1, and then this exponent times the coefficient, which is negative 4, and 1 from 1 is 0, and x to the 0 is 1, and 1 times negative 4 is negative 4. Okay? So now we have our special, our tangent line to the curve. Now we got to look for a special tangent line, and this is the special tangent line. The line that has a 0 slope, where m is equal to 0. Because that slope is going to be at the very top, or at where the line of symmetry is. Okay? So it's at the very top, and that's what's going to determine where the line of symmetry is. So now to find that, this slope has to be 0. This is a tangent line to the curve. So anywhere along the curve, this will tell you the slope of the curve. So if we want to know what when the slope is 0, then we set this equal to 0 and solve. So now I have negative 6x equals 4. And x equals 4 over 6. So x is equal to 2/3. Okay? So when x is equal to 2/3, that is when you have your point of your line of symmetry. This is your line of symmetry. So at 2/3, let's say it's about right here. If this is 1, does that make sense? Then x is going to be at 2/3. And so this is your line of symmetry. So now we need to find where on that line of symmetry is your y value going to be at its maximum, because we know that it has a maximum value now. Okay? So the y, where is y going to be at its maximum? When x is 2/3. So now you have to set up y is equal to f of x, which implies that we have f of 2/3, right, equal to this equation. So now we just plug it in. Negative 3 times 2/3 squared minus 4 times 2/3 plus 2. And now you do the math. and I'm going to pull it back over to here. So f of 2/3 is equal to negative 3 times 4 over 9 minus 8 over 3 plus 2. And now I have 3 and 3, so negative 4/3. Negative 4/3 and negative 8/3 gives me a negative 12/3 plus 2. Negative 12/3 is the same as negative 4 plus 2. So I have negative 2. F of 2/3 is equal to negative 2. So, at the point x is 2/3, the point of symmetry is equal to 2/3 negative 2. So at negative 2, 1, 2, we have our point. And now we have this. We have this this equation, and this is funny because it's asking us, when does it go through this point? Where are the x-intercepts? And we're seeing right here there are no x-intercepts. Are there or aren't there? Are there real x-intercepts or non-real x-intercepts? And from what it's showing me, everything I've done, which I hopefully did right, it's telling me that the intercepts are going to be complex, imaginary. Okay? So, the x-intercepts, let's find them. How do we find them? We find them by doing the quadratic formula. So, the quadratic formula the discriminant inside the quadratic formula should be negative. And let's see if it is. So, negative b. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we have negative b, negative, so there's a, b, and c. And so we have negative 4 negative 4 plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is negative 3, times c, which is 2, all over 2 times a, which is negative 3. And that pin's going out. So now I have 4 plus or minus the square root of 16 plus, uh-oh, that's not good. Minus 4ac, yep, plus, so I did something wrong over here, plus 4 times 3 is 12, times 2 is 24, all over negative 6. What did I do wrong here? That's right. That's right. Negative 4. Negative 4. No, that's 3 over 4. 3, 4, and, oh! No. That's minus. That's minus. That's 8 over 3. That's minus. That's minus. So that's more minus. So that's 4. And that's a positive 2. And that's correct.
Wait. Did you not square something? In the top, something's supposed to be squared.
Negative 3,
yeah.
x squared, unless that's not the point of symmetry, which it must be, right? 2, -3, -6, 4. It's 2/3. Is it -2/3?
It is.
It is. That's where it went wrong.
I
But
was
hey,
wondering
wait.
how it
Oh, that's still, because this is negative, that makes this negative. That's going to change something. This stays the same. This is negative. So it's -4/9. No, this is positive. 4/9. Or 4/3. Once we do that. Negative. But this is a negative and a negative, which makes it a positive 4/8 plus 2. So that tells me that I have 4/3 plus 2. And 4/3 plus 2 is 3 1/3. So now my point is at 3 1/3. So my point of symmetry, sorry about that, point of symmetry is going to be -2/3 and 3 1/3. And at that point, that changes a lot in here, because we have the point of symmetry is going, the thing is going to be x is at -2/3. So it's on this side. And the point of symmetry is at 3 1/3. So 1, 2, 3. Oh, and 1/3. About right there. And we know it's going to be frowning. So where will it hit? It's going to hit right here, wherever this is. And this is at 4 plus or